hit me up. And you can just do scott@solutional.com. That'll reach me too. Thank you all very much.
This is Surya, our chief data scientist. And the number one question that we get, I know I get, is where's the AI in Selector AI? So I'm going to hand it over to Surya.
Hey. Thanks, John, and happy afternoon. I hope after lunch we all. Let's try to keep this engaging. It's more of a discussion rather than a presentation of how Selector does AI. To start with, let's start some experiences of your own experiences with AI. Like, what are some wow effects and what are some may effects with AI that you had? Anyone wants to share their experiences with AI? Sure, please.
So I'm a developer, and occasionally I need to bring in a new library, and I've never used that library before, so I get the AI to do some work for me, and it feels like I'm in the Matrix. You know, when you go to the Matrix and you plug myself in, superpower. I know everything there is to know about this library.
Yes.
And then you write code, and you think it's good, and then you get it reviewed, and the first thing that somebody says is, "What the hell's all this AI slop?" What generally I found is, or what we found as a company is, AI is really good at writing code. It's actually terrible at writing tests.
Yes.
So we actually tend to write all our tests by hand.
Yeah.
Developing code actually is pretty good at.
Yeah.
And it feels like a superpower.
Totally. I have a slightly related experience to that. I also use AI tools. They're so good at generating their code, and I'm able to do a lot of work in such a small time.
Yeah.
But they are so sloppy in debugging the code. So, for example, I felt like you said, I had a superpower. When someone complained about some issue in some code which I didn't write, and then I tried to debug that code using Cursor. And Cursor told, this is the, I told the symptom and it told me this is the exact line of code. I felt empowered and I told everyone that this is the bug. And I was laughed at because it was totally wrong. Because that so yeah.
The other thing I give you is I feel like an AI connoisseur because if somebody sets up the code environment I'm in and they don't tell me which engine I'm using or which LLM I'm using, within a few prompts I like that. Yeah, that's ChatGPT.
Cool.
Yeah, this is cool.
Any other experiences?
I've seen when you ask the status of ISIS, it tells you that the terrorist organization is doing really well.
But AI has been beautiful to me. It has made a positive impact in my life. In one way, when Greg and I met last year, he recommended me this tool called suno.com, where you can generate lyrics. And he encouraged me to write a love song to my wife. And I used it, and it had a positive impact on my life. I couldn't lie to my wife. I told him I meant every word in it. I just didn't tell that I wrote it.
Are you going to sing it?
Oh, it would even sing for you. Yeah. So, we all are in a world where we know that AI is good at some things, AI is not so good at some things. So I want to start this session with that thing in the back of our mind. So there are certain things that AI does so well. There are certain things that humans do well. Right? So it's always, sometimes you feel like, why couldn't it do this part, right? And so that's where I think, as we discussed in the previous sessions, AI is not wise enough, but AI has a lot of knowledge and a lot of intelligence. So the right art to build real-world AI is to blend the right set of skills from humans and AI. Right? What AIs do well, you bring that in. What humans do well, you bring that in. And that's how you build real-world AI. The percentage composition of how much of it is human, how much of it is AI, it varies over time, right? And varies with expertise, varies with solution. But it always needs to have the human wisdom complementing the machine intelligence to make it a real-world outcome-oriented AI solution, right? I'll use this theme throughout my slides. Orange is for AI, and green is for the human component of it, right? So let's go deeper. So what does it mean in a real-world AI for networking, right? It's again, as we discussed in the previous slide, it's a combination of human plus AI. There are certain problems that humans can solve with good engineering, which fundamentally come in the part of the data engineering that we all touched upon in the morning sessions. So that part needs to be done very well. There is a specific problem statement that humans can solve better with, in the context of data enrichment. And then once you have a good foundation, then you have a better AI models which can perform to your satisfaction. But then to take them to outcomes, you really need to connect back them with the workflows and that the humans have designed. So this is the mix that we got right to build a good real-world AI solution at Selector. And I'll explain with different, I'll go deeper through the slides, but this is the big picture. Right? So let's go into this bottom part and then walk upstairs. Right? So when we talk about the data engineering aspect of it, right? So this requires a lot of effort, a lot of art and experience to be able to ingest the data at volume with reliability, right? And in a scalable model. Like because as AI is always, as you see more, you want to see more. Right, the value because now it gives you ideas about I can bring in my other data and let me see how that fits in this picture, right? So we need to have a variety of data ingest at the same time a highly scalable data ingest. So at Selector we have ingested like probably every possible data source that we have in the context of networking, but there is no end to it. Like there are new data points that are coming in. For example, we connect to existing data sources where like Splunk, Zabbix, which are already present because there is monitoring already in place. So we can ingest from tools like that. We can ingest direct SNMP and GNMI metrics from the devices. Again, through the boundaries of securities, we can have remote engines which can collect the data and present it to Selector. Logs. I can talk a lot about logs, but logs are really a key part that most of the monitoring tools just collect. But when you bring in AI to logs, it's a different game altogether, right? So we'll talk about logs. And if you have an existing data infra, we can connect to that data source using a message bus. If you already have the data on a message bus, we can tap into that. Right. So, but as you can see, most of the data falls in one of these categories, right? You can push, pull, or collect from a message bus. But then as the data volume increases, like you have 10,000 devices, 100,000 devices, you need to have a scalable model, which is where Kubernetes really comes in handy, right? How well you can scale out based on the data volume that is coming in. Right. So this is an unmentioned problem with any AIOps solutions, in any AI solution in general, because we need good data to get good outcomes. But you need to be able to ingest data at real time at high scale to be able to call it a good data to start with. Right. So that's why even before I go to the AI part, I wanted to stress on this part because this is one of the secret sauces. The second secret sauce is the enrichment aspect. So now we got all the data, and each data is telling its own view of things, its own view of the world. Like this interface has, this interface is flapping, this interface has some errors, but what is this interface? What is this link talking about? Where is it located? Which device? Which site? Which data center? All of that is the context that you need to enrich before you can do anything meaningful with that data. And where is that context? That's not coming in the raw data. This is where we need to be able to marry it with the metadata that is always present, that is present on the side in the form of spreadsheets, in the form of netbox, in the form of different ways of inventory management. So consider the inventories as another slow data, but the fast data that is coming as metrics and all can be joined as the data is streaming into the platform. To do this, you need to have a well-defined data enrichment pipeline. So we have a declarative ETL mechanism with which you can pull the right bits In fact, one of the important parts that we have observed was most of the secret information is buried in the interface descriptions. Right? The interface descriptions encode so much that if you decode it, you can get enough context about where it is located, a lot about that interface, especially its circuit IDs or its neighbor information, all of that. So all this now you got the raw data with few fields, but now we're able to expand this with a lot more context for every data point that you're ingesting. So what you're presenting to the AI is this reliably ingested data which is enriched with full context. And I'm gonna not say that it is a one-time exercise. It is an iterative exercise because the more insights you want, the more enrichment you want to provide and give. Sorry.
You regarding interface descriptions as reliable?
Yeah, great point.
No, that's fine.
So this is where it is contextual, right? There is, in fact, we have been in multiple deployments where part of the interface descriptions are reliable, part of them are fuzzy. So we need to have a validation pipeline onto that, right? So it is a completely real world problem because wherever humans are involved in tagging the interface names, tagging, humans are involved in doing something, it is subject to a fuzziness there. So how well you interpret it out. For example, there is enough data discipline to put in netbox. I mean, that's great. But I mean, not every deployment that we have has netbox in it, right? So sometimes the interface descriptions are what it is. So you have to deal with the data in incompleteness, if you will. Right? Yeah. So far, I haven't talked about AI. I've been on the human side of it. So, and to complete the picture, MCP helps us, like as the AI, imagine the AI does what it does. MCP is the one that is really being the connector. And MCP is really helping us to build those reliable workflows, right? And the way we have enriched MCP is that Selector has its own way of understanding natural language. So what it allows is, MCP is itself a language understanding tool, so it directs the messages towards Selector. So today morning we have seen a demo where it was asking Selector about some status of some devices. But Selector has its own natural language understanding which enhances that experience. Because now you are telling that you can ask Selector anything in natural language and Selector can understand. So for an MCP server, that's a big capability. And it's not just that, you can also trigger workflows to create maintenance windows, you can restart devices depending on the confidence level that you have. But MCP allows, again, to bring that human element to how to use the AI.
So it becomes complementary.
It is a complementary. So we have seen so far that we have done three things. We have taken the full stack, we have seen this part, we have seen that, the AI part. Now we'll go into the real AI part, what we call as AI. And I wanted to tell that when we started Selector on bringing in all these AI components, there were three key tenets of how we wanted to approach this problem. One is about, we wanted to make it data-centric. So there are two schools of thought in how you want to bring AI. One is a model-centric AI where the models become bigger and bigger and bigger based on how you train them and all. There is other way which is a data-centric AI where you know what the model does, but you get the data right because always good data trumps big models, right? So we want to get the data right in terms of ingesting the data, enriching the data in such a way that the models do what they are and they are reliable. Because now you want to be, you don't want to be stuck in a situation where you want to explain why the model hallucinated in such a certain way. Instead, what we have invested in is bringing these models, and we have fine-tuned the models, and they do a pretty decent job. But why do they do a decent job is because of the way the data is presented to that models, right? So if you look at any machine learning algorithm, once they are all tuned to react to certain data behaviors, and we have identified those right models which can react to those right behaviors. And that's where the data-centric model really helps. The second part is more about representative learning that we have, right? What I mean by the representative learning is every data point that is coming into Selector is treated either as a metric or a log or an event, right? And of course, a metric about an event or an event about a metric. What I mean by that is, if I'm seeing so many events, a device is chatty, and I'm able to compute that it is a chatty device based on how many times it is throwing those events, right? At the same time, when some metric is violating too frequently, I want to generate an event so that I can take action on top of that. So once you have this normalized view of metric or an event, now you build representations of that in terms of the context that we talked about, and this context allows us to build an embedding vector for every data point that we ingest. So as you all know, based on the GPT and all these models, embeddings are the key because they capture this information about the data that you're trying to learn about. So that's what this representative learning means. To be able to build that representations bring the context of what you are looking for. Last but not the least is the explainable aspect. This is very critical in the operations context because if you can't explain, you don't build the trust in the platform. If you don't build the trust, nobody is going to use the insights from the platform, right? Actually, the other day I was talking to my daughter, and she was like, she thinks AI. I asked her, "What is AI for you?" She says, "Like, oh, AI is it thinks it thinks and answers the data." I'm like, "Why do you think AI ChatGPT is thinking?" She's like, "It can read my mind. It can give me all these answers." I'm like, "But sometimes it makes mistakes." So she was so forgiving. She said, "Oh, that's AI is learning." Right, but in ops, people are not so forgiving, right? So yeah. So with that in those principles in the back of the mind, let's go into how Selector's AI is seen as, and how we build a selector model. Imagine there is a big selector model. I'm going to decompose this into different algorithms and models that in subsequent slides. But just like we think of ChatGPT as one big model. No, it has probably some 1,000-odd models, right? But imagine Selector AI is one big model. We can control the behavior of that model by using different layers of configuration. What we call it as Selector Software Modeling Language, or S2ML, is how we program how the labels can be enriched, how do you want to denoise certain metrics that are too noisy, that are not important. And you can go all the way till what kind of prompts you want to, based on how you want to see. That's because your target audience might want to see data in a certain way, right? But net, you can see that there is a configuration language, not a programming language. It's a configuration language which helps fine-tune Selector AI model. What it means is every customer of Selector gets their own Selector AI model, which is configured to their data, their context, and all of that using the S2ML. And that model resides in that customer's context. There is no data shared across Selector AI models because each model is instantiated. The iteration really happens in the S2ML part, like how well you want to see the model. Newer capabilities will keep enhancing in the Selector AI model, but the value that it brings, the outcomes that it brings, is real. This is the secret sauce, right? I'll pause here before I go deeper into what this model is, but any questions so far?
Do you have different models for managed service providers versus regular networks, like large enterprise networks?
So the way I want to answer that is there is one selector model again, right, which treats every data point as a metric or an event in a normalized way. The S2ML, the selector modeling language, is what determines the behavior of how you want to see. So if you want to see it in the context of a Major League Baseball or games and all, that's one set of labels that are specific to Major League Baseball. If you want to see it in the form of circuits and all, that's Lumen-specific context, right? So similarly, based on the kind of use cases that we've discussed, this is going to be the context or the knowledge base. And how the selector model works, which I'll explain in the next slide, is so agnostic to all of these. Okay? Yeah.
It's a declarative model, so you declare what you're looking.
I don't know if I can ask questions for the
Sure.
secret sauce. Okay. So
By the way, secret sauce is coming. Okay. Okay.
yeah, the only question I guess is that more like a RAG or is it fine tuning? Like how exactly? Or are you just indexing some of the information from customers? Like how are you saying that? Okay.
Let's answer that question after I go through this one.
Sure.
Yeah. Okay. Cool. Yeah. Yeah. Sure. No. Good question. Yeah.
So I think there's survivor bias here on logs, right? So you're only going to be looking at things that are there that you've got information from. What I mean by survivor bias is like those things that didn't get to you is also information because I haven't had any information from this and that. So is there an aspect of a model that can say, hey, you're missing this looks really bad, but so I would have expected I got this information that I can't find it. I mean, humans are really good at sort of
Yeah.
finding their way through survivor bias. I mean, I don't know how many network engineers are like, I haven't heard from router 6.
The way we have approached this problem is in the form of addressing the feedback, because initially the model presents what it knows, and then it's like there is an unknown that it didn't even know, right? There are some known unknowns, but that can be discussed during the time of building the solution by partner. This is where our engagement model with the customers really, like, it's not like a one-way thing. Like, you give us the data, we're going to tell you what it is. No, it's going to be always an engagement model throughout the journey. So that's where this refinement happens.
Okay.
Right. Because there is definitely a lot of human element to it, because every network is unique.
Yeah, it's just like, I mean, if I'm seeing this and I would expect I see this, and if
Yes.
I'm not seeing it, then that's an anomaly. So it's,
I'll give you a specific example.
Yeah.
What happens is sometimes the data comes, the metrics come at real time, the logs come with a little bit delay.
Always.
So now it's like, oh, you're struggling to like, I see some events which I cannot correlate with other things because they're coming with 2-3 hour delay.
deal with the hysteresis of
Right, so those are the things that the model can catch, but it's more like the UI and the way that you present it is amenable to feedback and how you get that information.
I have a question. Let me see if I can explain it in a very simple way. Regarding the secret sauce, right? What's the difference between your Selector AI model and something that's like a base or the actual LLM model that has come featured? So
Yep.
let's say, for example, like, let's talk about BGP, right?
Yeah.
I haven't tried some ChatGPT, like configure BGP and so on, right? What enhancement do you put for Selector AI, if at all it comes with some preliminary knowledge about BGP, right? I'm taking a very simple example here.
Yeah. So firstly, every LLM knows about BGP, but like I think there was a discussion about like, but would you use? I mean, those are not the kind of questions you are asking. You are asking questions related to your context, right?
So trying to see if I simple use case and see like
Yeah.
what exactly is the difference here.
Yeah. Maybe let's answer that question once I go to the models, right? Because I think I should go unless there are any other questions at a high level. Okay. So let's zoom into this Selector AI model. Okay. The model has a lot of layers to it, but I'll start from the bottom, right? And then we'll go higher and higher. So, as I said, every data point that we get is a metric or a log or an event, right? So what we do with metrics is we go through a stage of self-supervised learning. What does it mean, self-supervised learning? Is you look at the past behavior of the metric to identify a baseline for that metric. So which means now that you know that in the past 6 hours, depending on the type of the metric, or last 7 days, this has been the normal operating range of the metric. And anytime I see data point above that, I can kind of know that there is something anomalous happening. That's what this self-supervised learning is doing. And how do we achieve that? We do this is very traditional machine learning. Like what Scott told, this is going to be very reliable because ML does good at what it is doing. So what we do here is the statistical models help smoothen the metric. The regression models help predict the outcome of the baseline in a reliable fashion. So that's what really helps us compute a reliable baseline. And once the baseline is published, every new incoming data point is compared against the baseline and colored accordingly. So there is the kind of colors that you see, the greens, yellows, and reds, are the amount of degree of violation above the operating range that it is for.
So what you're saying is that you're using traditional machine learning to train these models real time, like a week in the past.
Yeah.
How do you prevent like overfitting?
Great. So firstly, the models are these baselines are continuously learned by these models. Right? So as the data is coming in, yes, we are doing an live inference with the baseline, but then there is imagine like this is like human brain. There is a system 1 and a system 2. System 1 is the one that takes instant judgment of any data that is coming in. System 2 is the deep thinker, which looks at a larger time window and identifies what is its behavior over time.
Right.
So, and that behavior, both of them are happening at real time.
So I think the question I have is, when you train a model, it can lose knowledge that it had before, right? The way it predicts can actually change. Like it can perform well, but now that you retrained it, it doesn't perform as well. How do you prevent that from happening?
Okay, two points to that. One, I think that applies more to the supervised learning aspect where every data is labeled and you are continuously measuring loss and all. In network ops, in real world, there is no supervised learning.
Okay.
Right? The data is always unlabeled. How you interpret the data, whether you use self-supervised or unsupervised, are your two options. Fully supervised is not an option. Right? The second part is how will you learn, keep memory of your past history into the future is important. Like you mentioned, the way we use it is the previously identified color of the data is also like you are computing the color based on the previously computed baseline, right? So this color is used to qualify whether the data point can influence your baseline or not. So assume certain data points overshot your baseline significantly. They don't add to your new baseline unless that behavior is constant. For example, there is a change in your network and you are now taking longer hops. Yeah, your baseline has to change. But if it is just a small spike, you don't use that. Right? So these are certain aspects that the past data tells you to compute baseline in the future. Right? But again, this is still self-supervised learning.
What if it's like a sustained spike?
A sustained. So there are guardrails. Like for example, you can never predict your utilization will be above 100%. Right? So there are model-specific guardrails. Right? Anything above 90% is always bad. So you have those things. But at the same time, if the peaks are sustained, you will be violate first, and then after some point the model has to learn. Then you learn, because otherwise there is no. There are always configuration options to not learn the sustained peaks. But I would let the model learn as long as it is within the guardrails.
So what you're saying is if it throws in like an invalid prediction, you can go back and say, unlearn it, or have you set baseline?
So again, how well you can describe this intent, right? So right, but the model has enough levers to configure these things.
Okay.
Right. But I would not normally I let the model as long as I'm giving the right data, quality data, I let the model decide.
I guess my question is, so you're continuously retraining this,
Yes.
and you're using transfer learning.
Yes.
Or basically, right? Can you tell me more about the metrics? Like, what are these?
Oh, so the metrics are all it can in a network context. I mean, we are talking in the context of networks today. We're talking about latencies. Latencies change over time, right? Interface errors. I mean, sometimes interface errors are always bad. Anything above 0 is bad for some things, but sometimes sustained errors are okay. Interface discards are acceptable because you are like, maybe there is a small congestion in the network and it will be okay. But there is some tolerance to those metrics. Right? I'm still at networks. I'm still at interfaces. I'm talking about the BGP and other states as well. Another important metric is the number of logs that are coming from a device is itself a metric. So if a device is chatty and like it sends 100 logs every minute, and all of a sudden it sends me 1,000 logs, then something is wrong.
What's an anomaly?
But if its device is very silent, like it doesn't send any logs, and even if it sends 10 logs, it's an anomaly, right? So that's, like I said, anything is that can be represented as a metric can be baseline.
Yeah, I see how that can be useful.
Yeah.
Even in manufacturing.
Exactly. So anything that can be represented as a metric, we are able to baseline and provide an insight into it. And again, it's still, we are yet to climb the whole stack.
We even have some security baselines, like if normally there's 10 logins in a day and now you have 1,200 logins,
Login failures especially.
that's suspicious, right?
Yes. Yes. That's about the metric part. I know we can keep talking a lot more. I'll move to the log part, right? So, there are enough tools that do metric monitoring in some form, but logs have been a unique problem because logs have been there from beginning, right? And the way people have been mining logs is using regular expressions, which are hard to keep up, hard to maintain, and my regular expression is hard for you. Your regular expression is hard for me to even understand what it is doing, right? So what we have taken is a natural language processing. In this world of language processing, we should not use regular expressions for logs. So instead, what we did was we did two parts to the logs. One, every log is an output of a print statement. So in a print statement, you have some English words, some proper nouns or specific words. So assume you are able to filter out the English words and the proper nouns, right? The English words tell you the print statement that it is really meaning. So assume you collect a lot of logs and you get a bunch of these print statements and you are able to identify, oh, I see this pattern of logs, sometimes with the device 1, sometimes with device 2, sometimes with a different location. But this is the same log pattern that I see. And now you're able to cluster them using unsupervised learning. So now what you see is your entire network fleet is sending you millions of logs, but they fall under maybe 1,000 patterns. Right? That's the first part. Now, like I said, we filtered out the proper nouns in the logs. They must be some entities like your devices, like your interfaces, that are very meaningful only to you, right? How do I know that these are meaningful to you? Because I have the metastore of all the devices and interfaces, anything from your netbox or from your CSV files, all the entities, all the metastores that you have, that's my source of information. Assume in plain English, I'm able to recognize city names like New York, San Francisco. How am I going to do that? Because I have a big database of all my my city names, and now I'm able to build a model that is able to do entity extraction out of these. What we are going to do is something similar, but with your data. Now I hope it resonates with you, like when I said each model resides only in your deployment. Because it is irrelevant outside your model, outside the context, right? So, but the algorithm, the way it is done, that is very, very, very specific to your deployment. Right? Yeah, so that's where the entity recognition models come. That's where the clustering models come. So with this, now you take millions of logs, you throw away because most of the logs are noisy. Because that's what you identify using your pattern recognition, that these are all noisy patterns. But then you capture events like link flaps, BGP flaps, all these individual, all these specific events, they are all captured into a set of log events. So now on one hand, we have metric anomalies, and on the other hand, we have log events. Right? All of them are happening at the same time in your network. Now, I can show one big dashboard of all these things happening, but wouldn't it be nice if the AI figures it out that there is some connection between all these things? That's where correlations come in. Right? And the intuition for the way we do correlation is through the recommender models, which we deal with almost every minute in our life. Like you watch a Instagram video, you get a recommended Instagram video out of that. YouTube has the same thing. Netflix is the same thing, right? We do the same. Imagine each of these event or an anomaly is a movie or a song. And whenever I see one event, I'm trying to find anything that has an overlap of labels, of enriched labels, because that's where the real context is coming from. I'm able to connect the dots across my different anomalies that are happening. Right? I hope you are able to see how everything is fitting in the puzzle. The enrichment enrichment didn't play a role so far. And, the raw data told me what are my interesting data points. Typically, we ingest, in any loaded deployment of Selector, we probably ingest like maybe 10 million data points every minute. But your network is not on fire all the time, right? There are only few things that are going bad at a given time. So what is happening is the number of anomalies that get transferred into this stage are probably in hundreds, maximum of 1,000, if you haven't put your filters enough, right? But when an outage happens, you see a big skew of these anomalies. And lo and behold, this correlation graph automatically captures all the similarities between those. And all of this is, in my mind, this is the real magic or the AI part.
Is that real time?
It's real time.
That's real time?
Because when I say real time, it is in the last 5 minutes.
That makes sense.
Yeah. Not because the model is slow, but because you have to wait for things to happen. Because certain protocols have certain amount of redundancy or some tolerance with which they report things bad, something went bad. But in 5 minutes, in a network, 5 minutes to 10 minutes is eternity, right? Everything bad can happen in that time. By the way, I haven't told anything about network redundancy here. At this point, the model doesn't know whether your network has redundancy or anything. It is just trying to correlate all the signals that it has observed. Okay. So once we complete this correlation, the layers above are the layers where you connect with, interact back with humans. Because now you have found something. How well do you present it, right? I just want to complete this part first because most of this so far has been reactive. But now, as you observe more and more anomalies over time, you are able to predict how they are trending into future. So this makes the AIOps solution, entire AIOps solution, very proactive as well. So now you know that which device is really taking a lot of time, is noisy, which one needs attention, which event is happening in your network. All of that is coming through your predictive analytics. So far, so good. All of this is good visuals and all. I'm sure if you show this graph to a NOC engineer, he is going to throw it back to you, right? It tells that there is a machine learning happening, but like, what do I do with this? This is where we bring in firstly, we bring in the causation model. So in this whole graph of events, what is the cause? What is what other things are effects, right? That is completely based on the set of events that we are able to correlate in a given time window. So imagine there is a link flap which caused a BGP flap. So link flap is the root cause, right? But assume there is a device reset that happened. So device reset causes link flaps, which causes BGP flap. So now, what is the root cause? Device reset is the root cause. Assume there is a power supply failure, and you have the data for that. I would like to qualify that. So you have all the data, and now you say power supply failure is the root cause, which caused the device reset, which caused the link flaps, which caused the BGP flap. So all of this causation is very contextual and case dependent, right? So, but the model knows all these hierarchies. One, based on the associations that it learns through graph neural networks. Algorithms are there to do some things, but we always want to provide a human override to address any data incompleteness or any human heuristics, right? So you bring in that information too. Net, this whole graph is now translated into a cause and effect reports. I know this text is hard to read, but there is a probable cause, what happened, and an impact. Right? Everything else is an impact, but the cause is highlighted. Because this is what a NOC engineer really wants to see. But that is possible only because you had this graph. That is possible only because you had these two. That is possible only because you had the enrichment. Anytime there is a data gap or low data quality, all of this, the outcome of this will reflect that. Right? So you're able to see the effects of correlations and causation. But to really present this data, you need LLMs in a way that the end users can relate to it. Because your NOC engineers' expectations are very specific to you. like how they want to read the incident, how they, all of those prompts, how well you present this data to the user is very important. But I want to highlight one part here. The way we interact with the language models, you already constrained the output that you are giving it. You're telling that I am telling you these things, present this in English with this prompt. Right? Otherwise, it would go hallucinating and being creative. Like I said, creativity only works when we are asking it for songs. That's a good use case, but not here, right? So so that's where the language models come in. Language models come in as an English layer on top of all of this learning that the platform has done. Okay.
Is it just have to be English, or could it be other languages as well?
Whatever the language models support.
Okay.
Yeah. I mean, language is there is no language barrier. So.
So you put my ops hat on. The first thing I do whenever I take over a new network is ask for the network diagram and where the fiber routes are. How do you get that information into the model? You just don't need it.
So if I were to repeat your question, I think we wanted to get the underlying circuit information, the fiber.
How do you get that into the model, or don't we even need it?
No, it is in the context. It is carried all through the model. Yeah. And when you are presenting it, the user wants to, actually you bring a great point. There I want, the prompt says, present the circuit ID ahead of everything else.
But it's only going to know about the layer 1 connectivity. I mean, how's it going to know where all the fiber routes go and all that stuff, right?
That's again in the descriptions. If it is in the descriptions, you present it, right? If it is not, the model cannot do anything. Right? I mean, it's always in the data. I don't want to give a false impression that the model is going to discover those things.
No, it can't, right?
Discover outside the data it has, right? It has to be in your metadata in some form.
Have you got a way of giving the model that context in a consistent manner?
Yes, we do give the data. This is where the RAG and RAG part comes in, because
how does that work?
RAG typically people see in the context of querying. Right?
Yeah.
We assume when we found a correlation and we want to produce an alert, even that is a RAG, right?
Is that the bottom or the top? So
it's on the top, actually. It's on the top. So the language models are how we present these insights into English words, right? So
I guess the idea is they're not using language models for anything except for just presenting the
that's what I'm thinking.
No.
They're extensively using machine learning, everything that's more accurate.
For accuracy, we don't rely on, I mean, one school of thought could be give everything to LLM and get the insights, pay the bill, and be fine with it,
But
right?
it's a dangerous school.
You will never be able to converge on that. But here, this approach, you are telling the language, bringing the language model once you have built the insight. But now, you want to provide your extra context, right?
It's the exact opposite way the human would do it. Because the human would go, where's the network diagram? And they assume context from that network diagram, I think.
Yes, you would start from top down, but now you have these correlation graphs coming in and presenting you that data.
An awful lot of hard work if you just did the engine, right? Like have the network diagram as well. If only we had
I'm coming there.
Yeah, okay.
The network diagram is what is not obvious here is that the enrichment that I talked in the previous slides.
Yeah.
Let me go back. So this is telling me where that circuit is.
Sure.
Okay, now when an anomaly happens, that anomaly is telling exactly what all its physical location. The LLM is only just presenting that data.
Yeah.
Because you are carrying this information all the way from this raw data.
I mean, you're inferring it from the data, right?
The data that is presented to the LLM to summarize has the complete context and the prompt. But it is also telling only this data to summarize. It's not telling, oh, this is all the data, you figure out what happened.
I would just so love a way of like giving it this extra information.
Yeah.
I can't give it in the logs.
You can try with varied success.
You can't even give it in the diagram, right?
I know, I mean, that's why I want to be able to give that information to network engineers as well, right?
Yeah, I mean, we tried like taking an image of a maze.
Yeah.
A maze and said solve for this maze.
Yeah.
And see if the LLM can do it. And it can't. I mean, not for complex mazes. And like, if you try to give an LLM a wiring diagram
It gets very confused.
and say how did I get from A to B, you can't do that.
Yeah. And that in a deterministic fashion. You can have one high moment, but after that it's like, once it fails, you don't know what to do.
Yeah,
Right.
twisted.
Right. Yeah, yeah,
Fascinating.
yeah. So now,
A quick question
Yeah.
on this slide.
yes, please. Yeah.
So I can see this traditional AI stack working for like data plane, right? Like you said.
Yeah.
Some road and light is not, on, and now your physically phased, and OSPF has a problem, then PGP will have a problem, right?
Yeah.
So for simple data plane stuff, I think I can see this working. It's a traditional AI stack without the power of reasoning, right? But how do you envision it working for more complex issues which are caused by the routing plane? Right?
Yes, yes.
Because routing plane requires the knowledge of how does routing work? This concept of NP and matches,
Yes,
right?
yes, yeah.
That's like reasoning,
Yeah.
And like longest prefix match is not a correct data match, right? You have to
I agree.
have reasoning.
I agree.
And then you have concepts of VPN, you have underlays, you have overlays. So you
Yes.
have to have some sort of knowledge and reasoning capabilities for really figuring out issues in the data plane that could be caused by the control plane.
Yes, totally.
How do you think
Okay.
envision targeting those kind of problems?
Yeah, without going too deep, I wanted to say that as long as we are able to represent your data in the form of a metric or an event with the right context, the model should be able to correlate and then present it. No, I'm not trying to dumb it down. I mean, that's a very easy answer to a very complex problem, right? So I would like to now start with how would you present it as a metric or an event? Right. So when you look at a routing churn, I want to be able to present that routing churn in some form, like either in terms of the type of log events that I mine, or from other metrics that I collect from BGP, or all of these. Only if I know that data, I can build some kind of a correlation, right? I can only say that there is some routing churn happening, then only I can say that okay, these things are correlated with the routing churn. Right.
So feeding the data is not an issue, right? Like somebody said there are protocols like BGP, which will tell you, advertisement.
Yeah.
But if you don't have the power of reasoning, how an LPM works.
No, I totally agree. We need to have that reasoning model. I mean, I'm not saying, but that model comes before you come here, right? So that comes in the data enrichment section. How well you build that? I mean, that is where the use case specific enrichment needs to happen. Right. I simplified the enrichment by just saying putting the neighbors and all, but in a complex cases, this is the kind of enrichment that you need to provide. Right. Once you provide that context, again, that alone may not be able to correlate, but it helps you summarize what happened.
So you're thinking of pushing down the complexity in the lower parts of the stack.
No. I'm saying I'm putting to the human part. See, some of these are not completely AI. It's like human plus AI, right? We need the human reasoning to be able to translate the raw data that is coming in into a metric or an event.
I think we could just call it as feature engineering.
Yeah, you can say so, but like how well you present this as feature is going to help with the rest of the stack.
So we really need some modules which would create features out of complex things like
Yes.
LPM,
Yes.
matches, and
Totally.
underlays and overlays of VPNs and things
And
like
provide that underlay overlay context, right?
that. I'm thinking of developing modules like that, which
Yeah,
would create features like that.
with proper data and proper validation. That's when I would say that problem is completely solved. Right? It's not because we are discovering newer scenarios in that, as you know, right? So I think that will complete that reasoning, right? But net, I think when it fits in this approach, but then the enrichment is a more complex exercise than a simple data enrichment.
It's a feature enrichment.
Yeah,
like
yeah.
you said.
Yeah.
So when you're building these clustering models, before you go up to the recommender model, right? So yes, I completely get it that this is purely networking context, we understand, but if you're actually managing a large backbone, you also have an administration utility partition or something, right? So what about confounders that come from the utility partition, say a buggy polar or something?
Buggy polar, yes.
So, I'm just using that as an example, right? So here you have a lot of false clustering that bubble up to the recommendation model.
Yes.
How do you shed those? I mean, I haven't used Selector so far, right? I have no visibility into this. Are we given visibility into the causation model, or do we consume it at a higher tier?
causation model, short answer is yes, causation, you have visibility into the causation model, right? In this layer, like how well the events are represented and all, you can control the causation hierarchies. You can override the machine learned causation hierarchies. Because sometimes human intelligence trumps, you know more than what the AI is bringing. Right? Yeah. But that's like a one-time learning, and then the model can iterate the causation.
What will be doing regression models? Sorry, I'm not an addition. So I know that that's a predictor. Do you do any clustering or unsupervised learning that can predict clusters and can predict why besides predictor?
That comes under the trend and prediction model.
Or you're doing that?
Yeah. Because we want to capture the patterns over time.
So you clean the data and then
This is more real time. This is more like over like last 7 days, last 30 days kind of a prediction. Yeah.
so you're letting the data discover clustering and what makes sense
Yes.
before it moves in.
Yeah. There are predictive algorithms here that come in, especially with if a fiber optics having issues. I think the errors keep incrementing over time. So then you know that okay, time to replace it, right? Last part is, as I'm sure John is going to do a more detailed demo on this. Like whatever you see on the dashboard, you can now have an AI summary live on the dashboard. And it can present you a complete view of what it is, what you are seeing, and why a particular thing is red. It is not just going to read out this slide. It is going to tell why a particular cell is red, why this is yellow, why the rest of them are green. It's going to summarize all of this. And to connect to what Nitin said in the morning, it can even say my parallels are fluctuating, right? So it can, right? So if they are fluctuating. Okay. Again, this is also based on the prompt and the LLM summaries that you can control. But net it is digesting all the information that you see and more in a dashboard summary. Right? I have a few questions, but if you have any questions, I want to first answer those, and then I want to go through this. Okay, let me start. I heard some of these questions from Ethan, so I wanted to, and I think very general.
Then what's the onboarding process? How do you enrich your data into Selector or fill out and use it?
Yeah. So I think there is, as I said, the answer for that is the selector modeling language, where you can describe your ETL intent as well, like how what data are you going to ingest, how you're going to enrich it. There is a detailed declarative ETL platform, and we have a GitHub repository that we co-develop with our customers, right? Mostly our solution engineers will get the initial set things working, and then all the fine tuning, any specific use cases varies on your team's expertise. I had to answer your question. Did I answer your question already? Okay. Did I answer your question? Yeah. Okay, cool. Thanks. Okay. So I just want to walk through a few questions that, in general, folks have about AI and machine learning models, because there is this mindset that there is a model that's always being that has to be trained, qualified every time. Let's talk about how do you bring the customer's data into the model. I answered that. Where does the model live? I hope we answered that. Like each customer deployment has its own model, right? And the model is private to that. And how does it need to be tuned using the Selector software modeling language? Right? How long does it take before customer gets a working model? My short answer would be 1 week. But again, there is a nuanced answer to this. There is the metrics that come in, they are learned in the first 6 hours of ingest. After that, you try to build a sense of it. 6 hours is the fastest time you can see something, but I would say 7 days is when you would see something meaningful, and in terms of when the data settles, right? So, and how do you translate the model from training to production? When you translate, how do you translate this? Is we always have a staging, initially we start with the proof of concept where everything is experimented and we come with the base model, and then it goes to production. And then you have a similar instance of it called staging instance, so where you try out a lot of new features, and then every time it is qualified on the staging, it is upstreamed into the production. Right. So that's how the model is validated. We have our own test cases for that, and we have customer acceptance tests The upgrades can be as frequent as 2 weeks, depending on the type of features. And that ties into the QA process, right? And once the model is in production, how does it keep with the constant data streams? Like we discussed, it does a lot of self-supervised learning, and then the rest of the algorithms play along with that. And any changes beyond that have to be validated on staging before they come into production. I just wanted to say that these are the qualities of a mature AI model in deployment, right? You can't just expect. You can get aha moments with few experiments, but to keep it in production, keep it alive for live on 24/7, we need to do all of this. Just like any other software engineering process.
So how long is staging? I'm sorry. How long is QA? Is that?
It depends on we look for aggressive, not aggressive, every 2 week upgrade kind of a cycle. But if there are no big requirements, you can keep. If the requirements are big, you can do it for longer cycle. You can always do it's a SaaS. So how well you want, how frequently you want to
Till you
upgrade.
feel comfortable.
Till you're comfortable. And what we normally see is till you get to maturity, the cycle is faster, but after that it plateaus.
So this whole process is weeks, not months or years, right? So to turn up Selector at a new customer, this is.
Yeah, I feel proud to say that, but yes, it is weeks.
And that's what the website says, right?
Yeah, it has to be weeks.
I could answer that. So I'm from the customer success. So really, it could be done in a matter of days, right? But it's really, when it comes down to security and access and everything like that, is a long pole. I've deployed many customers. Some I've done in 2 weeks. Some has taken months, right? We just got remote engines on there, right? It comes down to the nature of your business and your policies, right? But once they're on there and once you're doing some of the repetitive stuff, the rinse and repeats, we can get it done in days.
What about the false positive due to, let's say, maintenance events and decommissioning exercises?
Yeah.
How do you plan to do those?
So firstly, human feedback is the most important for that, and then we bring that into automation. For example, if you don't want certain trunk links or some devices to be because they are spare devices or something, you don't want them to be notified. Those can be marked in the meta store, and that will suppress the incidents automatically.
Yeah, you put devices in maintenance while you do this present, right?
Yeah, same thing. There is a maintenance window UI on Selector portal. You can configure the devices. You can post a maintenance window. We ingest even emails from customers because their vendors are sending the maintenance windows in emails. We parse them using LLMs. By the way, we found good use of using LLMs to parse emails, not just to summarize text. So, and then you understand what is happening, and then you suppress those devices for those time windows. Again, subject to that maintenance window being correct.
So basically, automatically you can get ticketing event, suck that data also from ticketing system, right?
Yeah.
And pass it
Yeah.
to an LLM and understand.
Yeah.
Does the device XYZ
Yes.
going to be decommissioned on this day?
Yes.
So any events because of that don't create.
Exactly. So one thing I didn't touch today is how well we create incidents out of these correlations. We saw the correlation graphs, how well they are summarized and all. But the real way the NOC team summarizes, consumes this insight is through ServiceNow incidents. That's like 90% of our use cases are like that. And there are identical workflows, other ways of consuming these incidents as well. So, but the incident descriptions are again prompt controlled and generated through that. But more than that, when there is an incident, that incident is created based, which is maintenance window aware, right? Because if there is a maintenance window, incident is not created. If there is an incident open already, the new correlation goes to it as an update, not as a new incident. Because you don't want to storm people with the incident about something that is already known, or if an incident is already open. And then there is an automatic incident detach, so that newer occurrences, if the incident is closed, you can create a new one. So all of this is part of a platform. I haven't touched up a lot on that, but that's how well the data insights are consumed by the end users. Yeah.
Where do you conduct your QA process? Because each customer's cluster is unique.
Yes. Great point. So what I was telling was each customer has a unique deployment, and imagine there is a staging version of this, so which consumes the same data, has the same configuration, and we use Git based mechanism. So a staging branch will be applied onto the staging version, where you can try out, experiment all of that, and then the QA happens. Then when the QA validates it, that's when it's ready for an upstreaming.
Is that something Selector does, or is that something that the customer potentially is?
So we have learned this practice by working with customers, and then that's turned out to be a good practice. So and this is our mode of operation.
My job is to get you guys to use the product as much as you can without me having to do that, right? So you can get hands on.
Yeah. So I think that is.
Thank you.